Hey folks, we're going to do a quick lesson today about circles. We recall that a circle can be represented by the equation x squared plus y squared is equal to r squared, where r represents the radius of the circle. Just a quick reminder that this is in fact the equation of a circle centered at the origin, and in grade 10 all you need to know is circles that are centered at the origin. So let's do some examples here. State the equation of a circle centered at 0, 0, given the following information. So in our first example, r is equal to 9, so I can just plug that into my equation. And I can simplify to give me a final equation of x squared plus y squared is equal to 81. Nice and easy. Next example here, r is 3 times the square root of 5. I'm going to go ahead and simplify this. I'm going to write it out. X squared plus y squared is 3 root 5 squared. Okay, when you square 3 root 5, you're going to do 3 squared first, so that's 9. And then the square root of 5, and then squared, so it's just 5. So the answer here is going to be x squared plus y squared is equal to 45. And finally, when we have a diameter of 5, well, the diameter of 5 implies that we have a radius of 5 over 2. So our equation is going to be x squared plus y squared is 5 over 2 squared. And recall, when you square a fraction, you have x squared plus y squared. You square a fraction, you have to square the top and the bottom. So our final equation is 25 over 4. Okay. Another example here, state the diameter of the circle. X squared plus y squared is 40. Recall, we are looking for the diameter here. Let's start by finding the radius. I can rewrite this as x squared plus y squared is equal to the square root of 40 all squared, which means that my radius is the square root of 40. Okay? The diameter is going to be twice the radius, so the diameter is going to be equal to 2 root 40. And you can approximate this by typing it into your calculator as being about 12.65 units. Okay, 2 more examples. Find the equation of the circle centered at the origin and that passes through the point 3, 4. Well, in this case, all we need to do is find r, because we recall that the equation of a circle, really the only number you need is the radius. We can find the radius using the Pythagorean theorem from 0. We can imagine I have a triangle here, okay? 3, 4 means that I am 4 units up and 3 units to the side. This is my origin, and this is my point 3, 4. We have 4 units up, because that's the y value, and 3 units horizontally. We can see this is making a nice right angle, so all I have to find here is my hypotenuse. Okay, we can find the hypotenuse using the Pythagorean theorem, which is the basis for the formula of a circle. 3 squared plus 4 squared is equal to r squared. 9 plus 16 is r squared. 25 is equal to r squared, and therefore 5 is equal to r. So the final equation of this circle is going to be x squared plus y squared is equal to 25. I didn't actually need to find the value of r. All I needed to find was the value of r squared, because that was plugging into my formula here. Our final example. A cell phone tower can pick up all signals around it following the circular area given by the equation x squared plus y squared is 400. If a cell phone is located at 1117, will the tower be able to pick up the signal? Justify. Okay, so we can imagine that we have a circle, okay, and it has some radius. We need to figure out if this is inside or outside of the circle. Basically, we need to figure out if the distance from our given point to the origin is larger or smaller than the actual radius. So first we need to find out what is the radius, and then we need to find out the distance from the origin to the point. And then these two we can compare. Let's start by finding the radius. My radius is going to be the square root of 400. If you know how to simplify your radicals, you can go ahead and do that now. This one comes out nicely to just be r is equal to 20. Now we need to find the distance from our point 1117 to the origin. In order to do this, we are going to use our length formula. We're going to do 11 minus 0 squared plus 17 minus 0 squared. This is just going to be 11 squared plus 17 squared, which is 121 plus 289. 121 plus 289 is equal to 410. We can approximate this at being about 20.25. Because the distance from the origin to my point is larger than the radius of my circle, I know that this is actually on the outside of the circle. If we were to draw a really quick sketch, okay, I have my origin here. I know that my radius is 20, and I know that my point is located somewhere over here. Let's take a look at what this problem looks like on Desmos. I'm going to go to desmos.com/calculator, and I'm going to type in, first of all, the equation of our circle. X squared plus y squared is 400. It's giving you this perfect circle here that you can see nice and clearly. Then I'm going to type in my point 1117. You can see it's pretty close to the edge of the circle, but when you actually zoom in, you can see it's on the other side. And you can, in fact, confirm that it is outside of the circle. When you're doing problems like these, and you want a quick visual, by all means, go ahead and use Desmos. I find graphing circles to be very difficult to do by hand, mostly because I don't have a very smooth hand, and it's more useful for me to see this here. Hope you enjoyed the lesson.